Hello everyone and welcome back to Teach Astronomy. My name is Victoria, but you can call me Vicky, and today is Monday, which means we are doing book stream. Also, if there is anything weird going on with my... Oh, there was. Hopefully I fixed it. I was going to say if there's anything weird going on with my mic, and if you hear me echoing a little bit, let me know, because I forgot to plug in the microphone before I started streaming, so I was worried that it was going to be like, what is this? But it seems fine. So, hello CJ SideQuest, how you doing? That's such a cute little emote. I've never seen that before. That's precious. But yeah, so today we are reading the next chapter in Dreams of Other Worlds, which if you haven't been here before is a book by Chris Impey and Holly Henry about unmanned space exploration. So last week, or the last couple weeks actually. Oh, hi. Oh, no, it's Anna. How you doing? The last couple weeks we've done, what's it called? The chapter on Voyager. This week we should be getting through the entire chapter of Cassini, because it is significantly shorter. Actually, all the chapters are significantly shorter now, so it should be like one spacecraft or space mission per week. So, yeah, so we're going to learn about some Cassini today. Let me move my keyboard. And you know what else I just realized I forgot? And I realized because there's a picture on the next page, I don't have the pictures ready yet. I feel so unprepared. I was early and everything, and still just never fully ready to stream. Okay, there we go. My pictures are set, and we are good to go. All right. Let's see. Cassini. Right rings and icy worlds. It is a drama as ancient as the sun, as unflinching as time, a never-ending whirl of celestial movements, scripted and precise, in a silent show of cosmic force, played out in light and shadow. It is a drama called Equinox, writes Cassini imaging team leader Carolyn Porco in her captain's log, an online diary of the Cassini spacecraft's observations of the ringed world of Saturn and its moons. It takes approximately 30 years for Saturn to orbit the sun, so the planet only experiences an equinox when the sun shines equally on its northern and southern hemispheres every 15 years. In August 2009, equinox returned once again for Saturn as Cassini explored Saturn and its moons. Quote, to its operators at significant remove, 1 billion miles away, it has been a long and gripping wait for this special season about to unfold, when the sun passing overhead from south to north begins to set on the rings, writes Porco. Observing Saturn in equinox from on site, she reminds us, is, quote, a solemn celestial phenomenon no human has beheld before, end quote. All of the large outer planets of our solar system have rings, though none as magnificent as Saturn's. The rings, no more than tens of meters thick, yet spanning nearly 155,000 miles in diameter, come into sharp and rare relief during the equinox, when the angle of the sun's rays is lowered relative to the ring plane and casts long shadows across the rings. And I actually already have a figure for you guys. It's not a figure, it's just a pretty picture of Saturn. Let's be real. There it is. She's beautiful. Actually, I'll leave that up while I continue this section, so you can look at pretty Saturn. In eloquent and poetic prose, Porco comments, quote, like the seas of earth, this wide icy expanse froths and turns, not by wind, but by the convulsive forces of Saturnian moons. This famous adornment, impressed deep in the human mind for 4 centuries as a pure, two-dimensional form, has now, as if by trickery, sprung into the 3rd dimension, end quote. Equinox on Saturn has since faded to northern summer, and we, along with Cassini, have observed the clear, deep blue skies of Saturn's northern hemisphere cloud over to reflect Saturn's signature peach or faded orange hue. Robotic explorers like Cassini have given us entirely new perspectives of other worlds in the outer solar system. Well, yeah, and that's the end of that section. She's beautiful, isn't she? It's such a cool picture. It looks fake. Just the way that like you would look at that and you'd be like, oh, that looks like a cheap Photoshop, you know, because the way that the the outline on Saturn is, but it's like, it's real. That's her. Yeah, and so the description under the picture says, Cassini spent 12 hours in Saturn's shadow in 2006 and took this image looking back toward the eclipsed sun. It's very, very pretty. Hello, Lynn Jersey. How you doing? Good morning. All right. How is everyone's morning going? My morning was rainy for the first time. And, well, okay, it rained on Wednesday too, which was shocking. But I love rain here. We get it like 3 times a year. All right. The cultural significance of Saturn and its rings. Saturn's ring system became etched in the human imagination sometime after the mid-1600s, when Dutch mathematician and astronomer Christian Huygens first illustrated the rings. He also was first to identify its moon Titan. However, in recent memory, it was Chelsea Bonestall's rendering of Saturn that brought the planet into the public purview. By training, Bonestall was an architect, but he's probably best known for the stunning paintings of Saturn published in May 1944 in Life magazine. The most famous and striking of these is titled Saturn as Seen from Titan. Readers were amazed by the suite of paintings that appeared in the May 29 issue, perhaps in part because the issue was largely dedicated to the news and advertisements related to the war effort. Among 130 pages of news reports on American soldiers in Europe, war-themed ads, and largely black and white photos of troops, Bonestall's realistic and full-color renderings of Saturn lumbering in the sky of Titan transported readers into exotic and delightful planetary vistas. Bonestall recounted how in 1905 he was inspired to paint the spectacularly ringed planet. Quote, "When I was 17, an important event occurred in determining my future career, although I little suspected it then." End quote. Having once hiked with a friend to Lick Observatory at the summit of Mount Hamilton, Bonestall recalled, quote, "That night I saw for the first time the moon through the 36-inch refractor, but most impressive and beautiful was Saturn through the 12-inch refractor. As soon as I got home, I painted a picture of Saturn." End quote. Although that painting was lost in the fires caused by the Great Earthquake of 1908 and 1906 in San Francisco, Saturn has made a lasting impression on the young artist. When nearly 40 years later, Bonestall submitted the series of paintings that included Saturn as Seen from Titan to the editors of Life, they quickly agreed to publish them. Ron Miller and Frederick Durant explain, quote, "No one had ever before seen such paintings. They looked exactly like snapshots taken by a National Geographic photographer. For the first time, renderings of the planets made them look like real places and not mere artist impressions." End quote. Miller and Durant wrote that Carl Sagan maintained, quote, "He didn't know what other worlds looked like until he saw Bonestall's paintings," while science fiction writer Arthur C. Clarke suggested that in a sense, Bonestall had walked on the moon long before Neil Armstrong and reportedly quipped, quote, "Tranquility Base was established over Bonestall's tracks and discarded squeezed-out paint tubes." End quote. And there is a picture of, there it is. So this is one of those paintings by Bonestall. So this was in the Life magazine. Let me grab that description. Read that for you. So Chesley Bonestall's Saturn as Seen from Titan made tangible planetary vistas human eyes had not yet seen. This iconic and influential image was an early example of the school of realistic space art that often informed and inspired the planetary scientists working to learn more about distant worlds. So yeah. You're missing spring break already. Yeah, it's an early spring break. I guess it's March. It's mid-March, so I guess that's pretty normal for some schools. It's so pretty though. I love the big rock faces and stuff. That's cool. All right. Hello, single coded. How you doing? Sanyukta said must have been an amazing discovery. Yeah, Saturn is that earlier picture is just astounding. Must have been very exciting to grab that. Okay. Wynne Waghorst had explored why Bonestall's famous paintings, Saturn is seen from Titan, is so compelling. Quote, "Since Titan is the only satellite in the solar system with an atmosphere, the giant Saturn looms low in a dark blue sky like an alien ship, a thin, gleaming crescent bisected by the glowing edge of its rings, afloat between jagged cliffs that jut from a frozen sea. A hint of dawn lights the far horizon, and beyond a lofty pinnacle, out under the glow of the great crescent, lies a distant path of noonday plain." End quote. Among the other bone still paintings in the life layout were imagined scenes of Saturn from its moons Phoebe, Ipetus, Mimas, and Dione. One depicted Saturn's rings passing overhead from the perspective of the planet's cloud tops. Wackhorst explains that the suite of paintings was intended to offer varying views of Saturn on approach from its outer moons. Though he painted numerous panoramas of planetary landscapes, ranging from Mercury to Pluto, Bonestell was aesthetically captivated by Saturn, a subject he repeatedly returned to throughout his life. He painted numerous iterations of Saturn from Titan and its other moons. In 1949, for example, he completed paintings of Saturn from Dione, in which the full body of Saturn is glimpsed from the mouth of a cave. His panorama for the Griffith Observatory, completed in 1959, featured a prescient vision of the frozen landscape of Titan, with Saturn low on the horizon. Throughout the 1960s, Bonestell reworked different views of Saturn from Titan, changing the lighting or subtly altering Titan's landscape. In 1972, he completed 2 separate paintings of Saturn from Ipetus. I hope I'm saying that right. As well as a painting of Saturn from Enceladus for Arthur C. Clarke's book, Beyond Jupiter. Bonestell returned to the subject of Saturn again and again in various configurations, settings, and lighting. All this from an architect whose work included contributions to the design of San Francisco's Golden Gate Bridge, the layout of the well-known 17-mile drive at Pebble Beach in Monterey, the eagle gargoyles and Art Deco facade of the iconic Chrysler Building in New York City, and the design of buildings for the California Institute of Technology in Pasadena. He became the highest-paid special effects artist in Hollywood, working on films like The Hunchback of Notre Dame and Citizen Kane. Bonestell's turn to space art played out in popular magazines such as Life and Collier's, and in films like Destination Moon, When Worlds Collide, and Conquest of Space. His work inspired generations to imagine the stark and beautiful planetary landscapes in our solar system and in far-flung systems of the galaxy. Bonestell brought the edge of infinity out of the abstract and into the realm of distant, direct experience, comments Sorry, guys. Bonestell brought the edge of infinity out from the abstract and into the realm of direct experience, comments Wackhorst. His paintings suggest planetary vistas human eyes had not yet seen, and sometimes included figures of astronauts dwarfed by a vast surrounding terrain. This was true of his paintings of Saturn from Mimas in the life layout, and of an iteration of Saturn from Titan completed in 1969, which situates 3 tiny astronauts on a cliff, looking out at a fully lit Saturn as one astronaut points to the rings. Bonestell apparently learned the technique for rendering his realistic paintings from science illustrator Scriven Bolton while working in the 1920s at the Illustrated London News. Bolton, a fellow of the... it's a morning, isn't it? Bolton, a fellow of the Royal Astronomical Society, constructed plaster cast models of planetary landscapes, photographed them, and then painted in planets and stars. Working from this technique, Bonestell would project light onto his plaster landscapes to get a sense of how sunlight and shadows might fall across terrain, and then painted based on photos of these lit scenes. This resulted in landscapes that seemed reachable and tangible. His widely celebrated renderings, quote, invited viewers into the possible planetary landscapes that exist on moons of the outer solar system. In Bonestell's depiction, Titan's landscape resembles that of the American Southwest, or perhaps the craggy cliffs of the Rocky Mountains in winter. That deep blue of the sky recalls that of Earth. End quote. Though such spectacular views from Titan may be unlikely given the moon's hazy, methane-rich atmosphere, Bonestell was prescient in suggesting the sublime experience of standing on the shore of one world to view another in close proximity. Wynne Wackhorst contends that Bonestell's art purposefully evokes, quote, a kind of cosmic shoreline, a composite of stark and eerie beaches on a near edge of the starry deep, and that the seashore is the root metaphor of Bonestell's art, meant to evoke Earth's horizon as the shoreline between Earth and outer space. Bonestell's art reminds us that from Earth we stand on the shore of the cosmic ocean, riding our wisp of blue and white like mites on a floating leaf, in the whirls and eddies of a great galactic reef. End quote. Carl Sagan wrote in Pale Blue Dot that humans have from time immemorial been innately drawn to the horizon. Ancient Egyptians identified their god Horus with the sun on the horizon and with the planet Saturn, thought to represent Horus the bull. The Great Sphinx in Giza apparently was associated with Horus and specifically is oriented toward and draws the eye to the eastern horizon. Without question, Bonestell's work inspired Sagan, whose first episode of the PBS series Cosmos was titled The Shores of the Cosmic Ocean. That's the end of that section. I'm going to grab some water. It's a lazy morning here. I feel like that's why I'm stumbling over some words here and there. Like I said, it's rainy, so it's like, it's not even still raining, but it's very gloomy, which is like a nice change to the normal constant sun, which like, I know I'm complaining about constant sun. Oh my God, you have it so good. I do. It's very nice here, but it's nice to see, it's nice to have a change every once in a while. But that also makes it feel like, you know, lazy and tired a little bit. But we'll see if we can get through this with less mistakes. All right. The lure of the shoreline. The seashore marks a liminal space and appeals to us in part due to the sheer tenacity of life to survive there, despite its harsh environment. Marine zoologist Rachel Carson characterized the seashore as a harsh but vibrant biome. Known primarily for her book, Silent Spring, Carson's area of expertise and real passion was the ocean. She published 3 best-selling books on the topic, but The Edge of the Sea specifically focused on the rigor necessary for species to survive in the hostile terrain of the shoreline. Describing the seashore as, quote, the place of our dim ancestral beginnings, Carson writes, quote, only the most hardy and adaptable can survive in a region so mutable, yet the area between the tide lines is crowded with plants and animals. In this difficult world of the shore, life displays its enormous toughness and vitality by occupying almost every conceivable niche. Visibly, it carpets the intertidal rocks, or half hidden, it descends into fissures and crevices, or hides under boulders, or lurks in the wet gloom of sea caves. Invisibly, where the casual observer would say there is no life, it lies deep in the sand, in burrows and tubes and passageways. It tunnels into solid rock and bores into peat and clay. It encrusts weed or drifting spars or the hard, chitinous cell of a lobster. It exists minutely as the film of bacteria that spreads over a rock surface or a wharf piling, as spheres of protozoa small as pinpricks, sparkling at the surface of the sea, and as Lilliputian beings swimming through dark pools that lie between the grains of sand. End quote. Celebrated anthropologist and naturalist Lauren Isley, Lauren Isley, in his essay The Star Thrower, similarly contemplated the formidable environment of the shoreline in Sanibel, Florida, which he describes as, quote, littered with the debris of life. Shells are cast up in the windrows. A hermit crab, fumbling for a new home in the depths, is tossed naked ashore, where the waiting gulls cut him to pieces. Along the strip of wet sand that marks the ebbing and flowing of the tide, death walks hugely and in many forms. Even the torn fragments of a green sponge yield bits of scrambling life striving to return to the great mother that has nourished and protected them. End quote. And I see that student McLeod found me a picture of, this is Rachel Carson, who is the writer of that long quote before from The Edge of the Sea. And that's one of her other books, Silent Spring. Yeah. There she is. Where'd my mouse go? There it is. Proud to be my wingmate. Yes, thank you. I appreciate it. Isley recounts walking along the beach and encountering a man picking up starfish washed ashore by the rugged waves. Isley pauses, and together the men notice a starfish that thrust its arms up stiffly and was holding its body away from the stifling mud. The man picks up the star and tosses it beyond the breakers back into the sea. At some point, Isley joins in the effort to save at least a few of the beach starfish. He describes lifting up one star, quote, whose tube feet ventured timidly along my fingers while it cried soundlessly for life, end quote. In such prose, Isley offers a snapshot of life's tenacity to survive in a threshold landscape. Evolved approximately 500 million years ago, starfish are ancestors to more complex organisms, including us. In that momentary embrace between Isley's fingers and the tube feet of the starfish, life primordial touches the present as two beings communicate a simple and mutually understood message, each wishing only to cling to life. Such vivid depictions of species surviving by a bare foothold or tubed foothold inspire us to imagine the distant shores on Titan, with its carved river channels and methane lakes, and wonder what microbes or variants of terrestrial mollusks might subsist on its frozen shorelines. While Bonestell painted his spacescapes at the dawn of the space age, we have since sent our spacecraft billions of miles from home, and in time we'll seek out the answers to what must have been Bonestell's questions regarding life forms that might cling to the rocks and crevices on Saturn's icy moons. That's the end of that section. Trying to open my water bottle with one hand. I don't know why I try. All right. Quick announcement. I'll make the announcement later too, but just in case I forget later. We had daylight savings yesterday. Woo, fun. Lost an hour of sleep. Oh no. But that means that since Arizona doesn't do daylight savings, the rest of the streams might be changing times. This one will stay the same, but Wednesday is going to move an hour back for everyone. It should be. So for me, instead of being at 11 a.m., it's going to be at noon because it's, in accordance with Michael's class schedule, and his class schedule isn't changing because their time zone didn't change. And then Friday I have to talk to Matthew about, but just to let you guys know, be prepared for that, and I will tell you when the time will be as soon as I know. All right, let's continue. A complex mission. In October 1997, a 6-ton spacecraft the size of a school bus set off on a billion-mile journey to Saturn. It was named after the 17th century Italian astronomer Giovanni Domenico Cassini, who discovered 4 moons of Saturn: Tethys, Dione, Iapetus, and Rhea, along with co-discovering Jupiter's Great Red Spot and first spotting the gap in Saturn's rings that bears his name. Cassini, along with its deployable probe Huygens, is one of the most complex and ambitious missions in NASA's history. Scientists can spend their entire careers working on a planetary probe like Cassini. The first concept was floated in 1982, and it got a boost in the late 1980s when it was conceived of as a joint mission with the European Space Agency. That helped it survive budget cutting by Congress in the early 1990s. More than 30 years after it was first conceived, it's still going strong. Cassini is an exemplar of international collaboration in space. More than 5,000 scientists and engineers in 17 countries have worked on the mission. It's still the heaviest spacecraft NASA has ever launched to a destination beyond the moon. To date, Cassini-Huygens has cost about $3.5 billion US, And the very high cost of complex planetary probes makes many people flinch. It was Cassini's ballooning budget in part that made incoming NASA Administrator Dan Goulden embrace a faster, better, and cheaper approach in the early 1990s. During the Golden Years, NASA... Sorry. It's a dumb thing to laugh at. I don't know if it was even intended as a pun, but the golden years. It's funny. Anyway, during the Golden Years, NASA launched nearly 150 payloads at an average cost of $100 million, with a failure rate of less than 10%. But the move to crank out more frequent, stripped-down missions at lower costs was not universally popular. A NASA report in 2001 argued that the strategy had cut too many corners and produced an unacceptably high failure rate. The public took notice when the high-profile Mars Climate Orbiter and the Polar Lander missions failed. The former was notoriously lost due to a failure to convert English to metric units, but the latter was successful in a later incarnation as the 2007 Phoenix mission to Mars. The debate may be a false dichotomy. Special purpose missions such as the recent L-Cross probe to the Moon and Mars Global Surveyor are only designed to do one thing. Oh, thank you so much for that follow of Galactic Stuff. Welcome to the TeachAstronomy family. That's a fun name. Where'd I go? Billion-dollar missions typically have a dozen instruments and are very versatile. They're like the Swiss Army knives of the space program. Among them, the two Voyagers and Galileo lasted 12 years beyond their design lifetimes and have fulfilled all their scientific goals. Cassini has finished its primary mission, and in 2008 it was approved for a 2-year extended phase called the Cassini Equinox mission. In 2010, it was extended until at least 2017 and renamed the Cassini Solstice mission. These names reflect the fact that the spacecraft will have witnessed an entire cycle of Saturn seasons by late 2017. So far, more than 1,500 research papers have been published based on Cassini and Huygens data, making this the most productive planetary probe ever. The mission will end with a dramatic flourish. Current plans call for Cassini to dive inside Saturn's rings on September 15, 2017, orbit Saturn 22 times, and then plunge to its death in the atmosphere. One hopes a musician will be inspired to write a suitably operatic theme for this planetary finale. That's the end of that section. And I hope it's been 4 years since that was apparently almost 4 years, 3.5 years, since that was supposed to happen. So I'm assuming that has already happened. Yes, it has. It did it as it said. It said September 15th. It would go down. So yeah, so the full mission duration was, is that right? Yes. So the full mission duration was 19 years, 335 days, with 13 of those years and 76 days actually at Saturn. So it took a little while to get there, but it's pretty cool. Didn't Cassini take the new version of the pale blue dot picture? I'm actually not sure. Let's find out. Cassini pale blue dot. Yeah, I mean, it's very possible. Yes, it did. Oh, that's beautiful. Let me find a big version. There we go. I'll show you guys. There she is. So this is a picture from Cassini, and you can see obviously this is Saturn, and we are right there. So it's like another version of the pale blue dot image that one of the Voyager spacecrafts took. So pretty cool. Pretty cool. Oh, and you have a Cassini-Huygens illustration. Beautiful. Thank you. I don't know why that wasn't already in the book, but this is the Cassini spacecraft with Huygens aboard. I actually am not sure what part is Huygens. Let me find a version. Labels. Trying to figure out how to... Tell me, where is Huygens? What part is the Huygens part? There it is. Okay. So if you look at this, you can see that and this is like an artist rendering, so it's not as clear, but the Huygens Titan probe is this part. So I guess it's right there. I think. I'm pretty sure. But yeah. Thank you for that follow, Flasterg. Is that your name? Welcome to the Teach Astronomy family. And it's a trajectory of... Oh, beautiful. Thank you for this. But yes, this is the trajectory of the Cassini spacecraft. So it starts round here on Earth, shoots out. It got a gravity assist. Oh, wait, there's Earth. Just kidding. What is this? Oh, did it go in first? That's very... We have not learned about its trajectory yet. But, looks like it did. But yeah, so it took off from Earth, went a little bit closer to the sun, and then probably needed to do that for a gravity assist to shoot off towards Saturn. And then it orbited around Saturn for years and years. Super cool. All right. Let's keep on going. You think Venus at least wants to pick up speed? Yeah, that would make sense why it had to go in a little bit first to come back out. They usually use gravity assist for getting to places in the solar system, so that makes sense. Okay. Flying rings around Saturn. At its closest approach to the Earth, Saturn is about 8 times the Earth-Sun distance, or 800 miles away. 800 million miles away. Yet, by the time Cassini reached Saturn, it had traveled 2.2 billion miles. NASA launched Cassini with the best rocket available, but it wasn't powerful enough to get the spacecraft to Saturn directly, since it would be fighting against the sun's gravity all the way. So mission designers used gravity assist. There it is. Colloquially called the gravitational slingshot mechanism, to get it to its target. As we saw in the last chapter with Voyager, this technique has been used since the 1970s to get nature's help in hefting planetary probes away from the sun's gravity. The assist is provided by bringing the spacecraft alongside a planet from behind and letting it get a kick from the orbital angular momentum of the planet. In principle, the spacecraft can get a speed boost of up to twice the planet's orbital velocity. Cassini passed by Venus twice, then the Earth, and finally Jupiter before heading to Saturn. The terrestrial flyby was controversial because of the nature of Cassini's power source. Solar panels aren't feasible for a mission so far from the sun's rays. So Cassini had 3 generators where radioactive decay of plutonium-238 generates electricity via a thermocouple. The power source had raised congressional eyebrows before launch, but as the flyby approached, NASA was told to do an environmental impact assessment on the possibility of Cassini impacting the Earth. For a worst-case scenario of a shallow angle of entry to the atmosphere and slow dispersal of the radioactive materials, the odds were 1 in 10 million. NASA was allowed to proceed. There were demonstrators and a few lawsuits, but the launch and flyby went off without a hitch, and now the plutonium is at a safe distance of 1 billion miles. These flybys were just a warm-up for the amazing series of gravitational dances that Cassini engaged in when it got to Saturn. Over its core mission, Cassini orbited Saturn 140 times. To see Saturn, its rings, its largest moons, and its magnetosphere from all conceivable angles, Cassini is using its rockets and 70 gravity assist flybys of Titan to tweak its orbit size, period, velocity, and inclination from Saturn. As the largest moon, Titan is the most useful in steering Cassini around the Saturnian system. Each Titan flyby is engineered to return Cassini into the proper trajectory for its next Titan flyby. Encounters with other moons are performed opportunistically with what's called a targeted flyby. About 50 are planned by the end of the mission, a dozen to the intriguing small moon Enceladus. From 2004 to 2011, Cassini did a dizzying 100 flybys, with another dozen completed in 2012. NASA hosts a clock counting down the time until the next swooping visit to a moon, and coyly calls these tour dates to appeal to a younger generation. By clever planning, NASA engineers have doubled the length of the mission, even though just a quarter tank of fuel remains. And we have a figure for that. There it is. Pardon the what is this? Comic Sans font up here. Not a fan. Found this one on the internet. This is not what is in the book, but the chart is what's in the book. So this says, the speed of the Cassini spacecraft relative to the sun during its first decade of travel. The early peaks are gravitational slingshot maneuvers to enable it to reach Saturn with the appropriate velocity for insertion into orbit around Saturn. The later variations are cleverly arranged flybys of Saturn's moons. So you can see, might be a little hard to read on your guys' end, but this says first gravity-assisted flyby of Venus, a deep space maneuver, second gravity-assisted flyby of Venus, a gravity-assisted flyby of Earth, gravity-assisted flyby of Jupiter. This is where it enters Saturn's orbit, and then these are all the times it goes around a moon. So yeah. Very cool. You're kind of new to astronomy. Is this the right place for me, or are you supposed to be a little educated about things in astronomy? This is the right place for anyone who wants to learn about astronomy. Also, if you are new here and you're a little confused why I'm just reading from a book, on Mondays we do a book stream where I read a chapter of, well, the book right now is Dreams of Other Worlds, which is a history of unmanned spacecraft, unmanned spaceflight in general. And but on Wednesdays we do streams about either about news or about specific topics in astronomy, and then Fridays we do amateur astronomy stuff where you can learn about telescopes and getting started stargazing and things like that. So yeah, this is a place for everyone who wants to learn a little bit about astronomy. This book might assume you know some things, but honestly the way that Professor Impey, who is one of the co-authors of this book, the way that he writes is usually pretty approachable. So hang out. And if you have any questions, let me know. I'll try to answer whatever I can. Also, regular disclaimer, I am not a astronomer. I do not have a degree. I have worked with an astronomy group for the last, oh my God, it's almost 4 years now. It's going to be 4 years in April. That's insane. But for the last 4 years, I've worked with an astronomy group. I am the kind of film and television kind of person, so I do the Twitch stuff. But I can answer some basic questions, so let me know if you have any. They can be off topic too, it's okay. And Student McLeod said, this is why you can't drive around Saturn on its rings while waving at your friends down below. You can see all the rocks. I'm pretty sure this is a artist rendering, right? Is this a real picture? I honestly don't know where you found this. I mean, it could be real. I actually am not sure. Let me know, Student McLeod, where you found this. But it's cool. It's funny. Do you usually do this at the same time? Yes, we do. I was actually talking about it before because our times are going to shift slightly because daylight savings was yesterday and half our team's in Arizona in the United States. Oh, it's only an illustration. Okay, that's what I thought. But half our team's in Arizona and they don't actually change times, which is so weird, but also makes so much sense and the rest of the world to do that too. But every Monday we are here at 10 a.m. Pacific Standard Time, and then Wednesdays is going to be noon. This is all in Pacific Standard Time because it's the easiest for me to understand, but it will be on the schedule in your time zone. And then Fridays we do, what time do we do Fridays? Normally we do 10, but it'll probably go to 11. But that after this stream, I'm going to update everything. So it should, on the schedule, maybe like 20 minutes after the stream, if you check that, it'll appear all in your correct time zone. Too many people think of the rings as a solid highway. Yeah, it's definitely not a solid piece of something. It's all, small rocky bodies and icy bodies and dust and fun stuff that honestly, I don't know how they flew Cassini into without killing it immediately. But maybe we will learn. I hope we will learn. It sounds very interesting. All right, let us continue. Titan's gravity has also been used to gradually tilt the inclination of Cassini's orbit, allowing it to see rings from above and below, and to see atmospheric phenomena of Saturn's poles for the first time. Flybys of Titan can't get closer than 600 miles, or the large moon's thick atmosphere would slow the spacecraft. Some flybys to small moons have been as close... Oh, apologies. I didn't have my caffeine this morning. Some flybys to small moons have been as close as 15 miles. At a distance of 1 billion miles, that's like hitting a golf ball coast to coast and dropping it within an inch of the hole. There's another problem with operating such a remote probe. Depending on where Earth and Saturn are in their orbits, the distance between them can vary from 8 to 10 astronomical units, or Earth-Sun distances. It therefore takes 70 to 85 minutes for radio commands to travel from mission control to the spacecraft, and the same for the reverse journey. Controllers can't give real-time commands. Even if they respond immediately to a problem, nearly 3 hours would pass before Cassini would get the response. This casts the flybys in an entirely new light, since the margin of error is less than a second. Yeah, I'm glad you found us of galactic stuff. Welcome to, like I said before, welcome to the family. We're all nerds here. Isn't that what, we have a follower and subscriber who comes in every time and says, hey nerds, or what's up nerds. So we're all nerds here. Welcome to the group. All right. Tools of the Swiss Army knife. The Cassini orbiter has 12 specific instruments, and the Huygens probe has 6. Tools on the Swiss Army knife fall into 3 categories: remote sensing using visible light, remote sensing using microwaves, and studies of the environment near the spacecraft. That's so funny, I've just realized that the figure that I had up before is actually a figure I already had. Oh well. But I will show you this figure while I read this section because it's about the different instruments. So, despite using 1,300 electronic components and 10 miles of cable, each of the instruments has worked as planned. Many scientific studies use data from more than one instrument. The optical remote sensing instruments are all mounted on a pallet so that they face the same way. The main camera on Cassini is the Imaging Science Subsystem, and it has been most people's entree into the exotic world of Saturn and its moons. Carolyn Porco, the principal investigator of the instrument team, maintains a website loaded with amazing images and evocative descriptions. As noted earlier, she uses a captain's log motif with affectionate allusions to Star Trek, and it's clear she's having the time of her life as Cassini images new worlds with unprecedented levels of detail. She's compared a leadership role in a big space mission with child rearing, a journey of thrills and heartache, excitement and occasional disappointments, lasting 20 years or more. Even the most jaded cynic about big science would be entranced by the best pictures from the main imager. 2 mapping spectrometers. I'll switch back now, unless you guys want this up instead. I don't know if y'all like looking at my face or at the spacecraft. I'll leave the spacecraft up. 2 mapping spectrometers look at the properties of Saturn, its moons and its rings at optical and infrared wavelengths. This is the key to determining their composition and temperature. An ultraviolet spectrometer does the same thing at shorter wavelengths that the eye can see, as another guide to chemical compulsion. Composition. I'm sorry. Cassini can't capture samples of the atmospheres or rings, so remote sensing with spectrometers is the best guide to chemistry. The spacecraft's microwave remote sensing instruments function a bit differently. Optical remote sensing just uses available light or radiation reflected from the planet, moon, or ring particle. Cassini has to generate its own radio waves and microwaves, send them to the target with a 4-meter high gain antenna at one end of the spacecraft, then listen for a weak echo signal. The radar instrument can penetrate Titan's atmosphere and so make topographic and compositional maps. It can also see deeper into the atmosphere of Saturn than any other instrument. The radio instrument looks for fine structure. It also makes Doppler measurements that allow the masses of Jupiter's moons to be precisely calculated. A set of onboard instruments measure heterogenic particles, ions, and magnetic field strengths at the position of the spacecraft at any time. Here, the complex orbital gymnastics are essential. To make a map of these properties, the onboard instruments need to sample data from as many locations within the system as possible. Several of the 6 instruments are devoted to understanding Saturn's magnetic field via the charged particles that it often accelerates. To avoid overspecialization, NASA selected 6 teams of interdisciplinary scientists. Their job is to use Cassini's instruments in concert to maximize the learning and perhaps answer questions that hadn't been anticipated. All this instrumentation is power hungry, and like other probes to the outer solar system, there isn't enough sunlight for solar panels, so Cassini uses 72 pounds of plutonium. And there she is. I have returned. The sun has come out, so it may start putting streaks on my face. And if so, we're going to close the blinds. But we're going to wait it out, because I do like the lighting. When you're too cheap to afford a ring light, you just put your computer in front of the window. All right, what Cassini discovered. Cassini has rewritten the book on Saturn, making many scientific discoveries. The first 6 years of study were summarized in 2010 in 2 papers in the journal Science. 2 of the greatest advances were conceptual. The first was to paint a sharply etched portrait of a gas giant planet and its moons as intriguing worlds with personalities and quirks that made them noteworthy. Voyager paved the way, but Cassini got closer to its targets and spent a larger amount of time in their neighborhood. Another realization was the plausibility of the outer solar system for biology. Although far from the sun's warming rays, the largest of Saturn's moons get internal energy from radioactive decay of their rocky material, and many of the moons get extra heat by being tidally squeezed by the gravity of the massive planet. If life's minimum requirements are energy, liquid water, and organic material, these conditions may be met on a half a dozen of the moons of Saturn. This animates the search for life elsewhere in the universe, since giant planets with attendant moon systems are expected to be commonplace. Not all scientific data are equally digestible to public audiences. Spectra or measures of magnetic field strengths and charged particle fluxes are abstract and esoteric without a lot of background information and context. So the general awareness of Cassini has been based on its imaging. In that respect, the imaging science subsystem is preeminent. And ISS team leader Carolyn Porco has been an eloquent spokesperson for why we should care about the outer planets and their moons. The portraits made of the Saturn system, best seen at a glance in a poster mosaic of 64 scenes from Saturn on the Cyclops.org website, are an eloquent testimony to the interplay of shadows and light in the realm where there's no air to diffuse and scatter light. The shadows of moons fall on rings or on each other, and shallow angle light casts deep shadows on the hills and pockmarked surfaces of the moons. The chiaroscuro is worthy of Caravaggio. In fact, there's an unbroken lineage in the natural depiction of strong light and shadow that connects Leonardo and Galileo's sketches of the moon, Bonstell's paintings, and the actual images from Cassini. My plant hates the dark. Where is she? She's over there. My plant hates to grow. I don't know what's wrong with it. She's fine. She hasn't died, but she also just doesn't grow. Also, Catsleaf said that you recommend Professor Impey's MOOC classes. They are great. That is kind of why this whole channel exists, if you found us differently. But Professor Impey does some free classes on Coursera and I think Udemy or whatever Udemy is now. And teaches the public. It's really cool. How does that walking carbon-based unit think? I don't close the blinds. I only close the blinds when we're streaming. I always keep the windows open, but like sometimes the light is just very, very, very bad. But I don't deprive my babies. My plants get plenty of light, trust me. Does Cassini observe Saturn in all kinds of light? Well, it seems like these instruments, so it observes in optical light, and it uses those radio, like I was saying, one of the instruments bounces radio waves off of whatever it's looking at. So that could be the planet, it could be one of the moons, or it could be some of the debris in the rings. I don't believe it has anything to read X-rays. I don't think so. Unless I missed that. But definitely optical light to get those pictures, radio waves, and then it has some instruments to measure like magnetic field strengths, ions, particles, stuff like that. So I don't believe X-ray or UV because I don't know if there's she's very close to the window. This is a small room. This is a very small room, I swear. I'm not mean to my plants. Maybe I'll put her, I have a little shelf here that you can't see underneath this. Maybe I'll start putting her on there instead. But yeah, I don't believe there's anything on there that looks at UV. I'm pretty sure, or at least like not specific. I mean, I could be wrong. I'm not positive, honestly, but definitely primarily radio and optical. All right, let's continue. Let's continue while you guys keep calling me a bad plant mom. Go ahead. I'm kidding. I have other plants that aren't in this room and that aren't rubber plants. And if you think, I mean, it's a fake plant. It's not a fake plant. A rubber plant is a type of plant. It has another name. I don't know what it is. But I have other plants in other rooms in the house, and they're doing fine. And she's doing fine. She just doesn't want to get any taller. It's okay. I don't want to get any taller. That's why I stopped growing. Okay. Let's see. Where was I? The science started flowing long before Cassini got to Saturn. As it passed Jupiter to get a gravity assist, the spacecraft took 26,000 pictures and studied the circulation patterns that produce counter-rotating atmosphere bands on the giant planet. It also provided evidence that Jupiter's faint ring originates from micrometeorite impacts on the small moons. Cassini gave a nod to Albert Einstein with a new test of his general theory of relativity. Gravity very slightly bends and slows down light and any other form of radiation passing a massive object. Cassini sent radio signals past the sun to the Earth so this delay could be measured. The results agreed with the predictions of general relativity theory with a precision of 1 part in 50,000, improving on the precision of previous tests by a factor of 50. In 2004, Cassini discovered 3 new moons of Saturn, bringing the total to 61. They're small, between 3 and 4 kilometers across, like free-floating mountains in space. A year later, it found a slightly larger moon in one of the gaps in the rings. The moons and rings engage in a complex gravitational waltz. Some gaps in the rings are caused by a moon clearing out particles at that distance, but others are caused by a more distant moon driving a resonance. If orbits have periods that are related by the ratio of 2 small integers, then the outer object can influence the inner one, and in the case of an outer moon, it clears out a gap in the rings, as described in the last chapter. Since there are many moons, there are many ratios that can cause resonance. Harmonic effects like this cause much of the complexity of the ring system. They orbit silently in the vacuum of space, but ring and moon systems have the timbre of a beautiful musical instrument, each one unique. Cassini's arrival at Saturn in July of 2004 involved a daring and risky maneuver. It shot the gap between the F and G rings, equivalent to threading the eye of a needle. The high-gain antenna had to be pivoted away from Earth and along the flight path to protect it from hits by small particles. And then the rockets were used for a very precise deceleration that allowed Saturn to capture the spacecraft. At its closest approach, it skimmed just 13,000 miles above Saturn's cloud tops. Imagine the majestic view if humans had been along for the ride, watching the towering cloudscapes of a planet so big 760 Earths would fit inside. Cassini provided fascinating new details on the ring system. To a casual observer, it seems miraculous that such subtle and complex patterns could arise by unguided natural processes. But the gravitational mechanisms behind the rings have been known for decades. Cassini measured the size distribution of ring particles more accurately than before, and its data showed how ring particles can join into loose aggregations or piles of rubble. And it found instances of moons stealing particles from rings, as well as times when moons eject particles. New data showed that the rings are 90% water, so they're most similar to a huge bumper car ride with careening chunks of ice of all sizes, from microscopic to the size of a house. Surprisingly, when seen up close, the rings are tinged red, which scientists speculate is due to rust or small organic molecules mixed in with the water ice. To the connoisseur of gravitational dynamics, there's a life's work in understanding the shifting spokes, the spiral density waves, the embedded moonlets, and the features that look like waves in straw and rope. And it said that there was a picture there's like a full color section in this book, and every once in a while it gets referenced, and it's been referenced. Oh, it's an artist impression of it actually looks very similar to the one that Stu McLeod sent before. So it looks like this, but so yeah, you can see it here. So some of these, again, this is just an artist impression, but like some of these can be, microscopic pieces of little dust and stuff, and then some of them are, the size of a house. And yeah, like of galactic stuff said moons in the gaps of the rings have been found, yes, which is crazy. I don't know how they, I would love to, I don't know if they'll mention it in this, probably not, but, I wonder what the actual, cause I actually have never thought about it much, what the line is between just a piece of debris in one of these rings and a moon, especially if they're finding a moon in the rings, what size threshold do you have to pass to be a moon? All right. Much of the time thereafter has been spent planning and executing flybys. An early passage near Phoebe was the only one that will be possible for this curious little moon. Phoebe is one of the outermost moons and only 150 miles across, but parts of its heavily cratered surface appear very bright, and scientists think there's ice under the surface. The lion's share of the flybys have been used to explore Titan. Titan is the second largest moon in the solar system. Only Jupiter's Ganymede is larger. Titan is 50% larger than the Earth's moon and nearly twice its mass. It is unprecedented in having an atmosphere thicker than Earth, made of the same primary ingredient, nitrogen. Setting aside episodic lava flows on Io, it's the only object beyond Earth where stable bodies of liquid have been seen on the surface. Cassini has used radar to penetrate the thick murk of the atmosphere and reveal surface details as small as a kilometer. Titan's orange haze is naturally produced photochemical smog. Methane and ethane are mixed in with the nitrogen and they form clouds and rain which fall on the surface. There's weather here, but it's a completely alien chemical environment. Other trace ingredients include propane, acetylene, argon, and hydrogen cyanide. Add some oxygen and you'd have the recipe for a real conflagration, and it's not anything humans would want to breathe. Hydrocarbons break up and recombine in the upper atmosphere under the action of sunlight. The methane present would be converted into more complex molecules in only 50 million years, suggesting that it may be replenished from Titan's interior. Robert Zubrin pointed out that the base of Titan's atmosphere is so dense and its gravity is so gentle that astronauts could potentially fly by wearing powered wings attached to their arms. The real prize on Titan is not the chemical haze in the atmosphere, but the glittering liquid on the surface. In late 2009, NASA released a gorgeous picture of the northern polar region, backlit by the sun, with a glint of specular reflection from a body of liquid. Other images show that the liquid levels do not vary by more than 3 millimeters. There's little surface wind on Titan. The north and south polar regions are dotted with lakes varying from a mile across to larger than the largest lake on Earth. The main ingredients of the lakes are likely to be methane and ethane, with smaller contributions from ammonia and water. Evaporation from the lakes is not enough to supply the methane seen in the atmosphere, implying even larger reservoirs of liquid methane underground. Titan is literally swimming in organic materials. There's hundreds of times more mass of liquid hydrocarbons on Titan than the sum of all the oil and gas reserves on Earth. Oh, and that's the end of that section. A moonlet? Yeah. Is a moonlet a term? A specific term? I wonder. Looks like we have about hit the hour mark. And we have, this chapter is delightfully shorter than the last one. The last one was like 38 pages or something like that. This one's only like 26. Which means that we can get through it today. Is it getting too bright? The lines are coming. Can you see them? I can see them. I'm going to close this over a little bit. Here. Look at Saturn for a second. Hold on. Wow, she's beautiful. Look at Saturn. Beautiful. I've returned. Oh, you see that little line though? Sorry. We're gonna leave it. Oh well. Okay. Whew. The next section is Huygens pays a visit to Titan. The centerpiece of Cassini's symphonic mission, a brief aria of great excitement and beauty, was the descent of the Huygens probe to the surface of Titan in 2005. Titan is the most Earth-like world in the solar system. Oh, hello, Sniper Hermit 27. Thank you for the follow. Welcome to the TeachAstronomy family. Titan is the most Earth-like world in the solar system. It has weather, erosion, active geology, and a complex topography of lakes and rivers and floodplains. 3 billion years ago, when the sun was dimmer and no oxygen had been pumped into Earth's atmosphere by microbes, the two cold worlds had strong similarities. Huygens represented the main contribution of the European I was thinking Europa. Main contribution of the European Space Agency to the Cassini mission, and even though it returned a modest amount of data, it was not a disappointment. On December 25th, 2004, the probe separated from the main craft and began its perilous descent. Buffeted by winds in the upper atmosphere and unable to get a navigational lock on the sun due to the thick smog, it slowed by parachute and landed on January 14th, 2005, on what appeared to be a floodplain, scattered with cobbles of water ice. Since the surface conditions of Titan were unknown, Huygens was never designed to be a lander. Rather, it was designed to survive landing on any surface, from rocks to ocean, and transmit a small amount of data before expiring. This was dictated by the limitations of the batteries, which only had 3 hours of life, much of which was taken up by the descent. There was one minor disaster in the mission, when a software error prevented some of the lander's images from being uploaded. While 350 images were returned, a similar number were lost. There was also a major disaster averted. Long after launch, some dedicated and persistent engineers discovered that Cassini's communication equipment had a major design flaw which would have caused the loss of all Huygens data. The probe had to send its data by radio to Cassini's 4-meter antenna and then onto Earth. However, the acceleration of the probe would have Doppler shifted its data out of range of the Cassini hardware, and the hardware could not be reprogrammed. To salvage the situation, flight engineers changed the landing and flyby trajectory so that the Doppler shift was greatly reduced. Huygens weighed 700 pounds. Oh my god, why? Sorry. It's so heavy. Huygens weighed 700 pounds and carried 6 scientific instruments, most of which had been designed to study the atmosphere. A microphone on one instrument captured the first sounds ever recorded on any planetary body apart from Earth. Another instrument mapped wind speeds at all elevations down to the ground. A third carried a lamp to illuminate the surface, which was useful, since Titan is a very murky moon. Oh, apologies. Huygens team member Martin Tomasco recalled, quote, "We had great difficulty obtaining these pictures. We had only 1% of the illumination from the sun. We're going into a very thick atmosphere with lots of haze that blocks light from penetrating to low levels, and we're taking pictures of an asphalt parking lot at dusk." End quote. A fourth instrument did the clever trick of heating itself up just before the impact so it could analyze the vapor that came off the surface. The surface was a frigid negative 290 degrees Fahrenheit, or negative 179 degrees Celsius. Cold enough that ice is brittle and methane is a liquid. Scientists clustered around monitors in the mission control room got to stare at a bleak and remarkable scene for several hours, longer than the expected 30 minutes, before the batteries finally died. That's the end of that section. All right. Big surprises from tiny Enceladus. Before Cassini arrived at Saturn, astronomers had paid little attention to Enceladus, a moon 1/10 the size of Titan. The Voyagers had shown sorry. The Voyagers had shown in the 1970s that Enceladus was like an icy billiard ball, reflecting almost 100% of the sun's light. Its surface gave indications of activity since some parts were old and heavily cratered, while others seemed to have been altered by volcanism in the last 100 million years. But nothing in earlier data prepared scientists for what Cassini would reveal. In 2005, plumes were seen rising from the fractured icy surface. It took several... Oh, I have a picture. Let me show you the picture of the plumes. Ooh, amazing. Plumes. Oh, nope, too far. There it is. So those are the plumes they're talking about coming off of Enceladus' surface. It took several years and numerous observations by Cassini's instruments to build up a piece of what was going on, or build up a picture of what was going on. But this is what we know. Enceladus emits geysers of tiny ice particles from a number of hot spots on its surface, near the southern polar region. The plumes are ejected at over 1,000 miles per hour, greater than the escape velocity. They rise thousands of miles above the surface and form Saturn's E-ring. The geysers arise from geological features called tiger stripes that are 100 to 200 degrees Fahrenheit warmer than other areas of the moon. Geologists think there's spreading and tectonic activity in the tiger stripes, similar to what happens near deep-sea ocean ridges on Earth. Tidal heating must play a role, but the cause of the active geology on Enceladus is still a mystery, since the neighboring and similarly sized moon Mimas is inactive. Cassini has swooped through the plumes on several occasions, 3 times approaching the moon within 30 miles, tasting the material with its instruments to determine the chemical composition. The plumes are made of tiny ice particles and vapor that includes methane, ethane, propane, acetylene, and other organic molecules. The chemical composition may be like a comet. Most excitingly, the plumes contain sodium chloride, common salt. That's the best indication so far that Enceladus has a subsurface ocean that occasionally erupts through the surface. Much of this information was gathered in a series of swooping flybys, the closest of which zoomed within 15 miles of the surface. The imaging team called these maneuvers skeet shoots. The spacecraft is moving so fast and is so close to the moon that the camera can't track or lock onto any particular geological feature. Some images resolve features as small as 10 meters across, about the size of a living room. In late November 2009, Cassini made its 8th flyby of the tiny moon, the last before Enceladus entered the shadows of the long, cold Saturnian winter. With no new mission slated to arrive to the outer solar system for at least 15 years, it will be a while before we see images like this again. Meanwhile, the presence of liquids on Titan and inside Enceladus naturally leads to speculations about biology. Our dreams turn to the possibility of creatures floating in the dark and frigid depths of lunar seas far from their sheltering stars. That's the end of that section. It's a beautiful picture of those, the plumes. Oh, and you sent me another picture. Ooh, gorgeous. So here's another image that Student McLeod found of those plumes again that are being backlit. It's so cool. Ooh. Had to yawn again. I skipped my coffee this morning. I really should have had it. But yeah, this is pretty cool. So also, if you know anything about some of the newer missions that are in the works right now, I believe, what mission is it that's going to be going to a few different moons, I think? The Enceladus Life Finder. It's a proposed mission. I don't know if it's actually been confirmed. Or now it's called Orbilander? No, it's the Enceladus Life Finder, right? It was proposed in 2015. And then again to 2017. In 2017, but it wasn't picked. But, which I don't know why it wasn't picked. It should be. But Europa Clipper and Titan's Dragonfly are both going to be missions coming up. Europa is a moon around Jupiter. That's not wrong, right? Let me just make sure. Yeah, it's Jupiter. It's called Jupiter too. It says Europa or Jupiter too. That's very cute. Baby Jupiter Jr. Yeah, Europa Clipper and Titan Dragonfly are two missions that are going to be going to these moons of the larger gas giants soon, and hopefully an Enceladus mission would be added to that soon because Enceladus seems really interesting. Oh, I'm glad, Keaton Stone, I'm glad you're enjoying it. I hope work is going well for you. Did I just... Okay. Let's keep on going. Okay. Earth's oceans as analogs for extraterrestrial seas. In Alien Ocean, Anthropological Voyages in Microbial Seas, Stefan Helmrich argues that the discovery of life deep in Earth's oceans provoked increased speculation about the possibility of life in extraterrestrial seas. Prolific communities of tube worms, krill, and other hypothermophiles were discovered near deep-sea hydrothermal vents in 1977 in the Pacific Ocean. These organisms live in complete darkness. No sunlight can penetrate to these depths. Scientists speculate whether life in primordial times thrived in the sulfur-rich heat plumes that spew nutrients from the ocean floor. Besides the fact that we believe all life on Earth originated in the sea, we've long imagined, notes Heimrich, that extant primeval life forms might somehow survive in the deep even today. Life's origins may be best represented by extremophiles currently living in extreme environments. He writes, quote, "Some marine microbiologists maintain that vent hypothermophiles are the most conserved life forms on the planet, direct lines back to the origin of life." End quote. What we are learning about extremophiles, or methanotrophs, bacteria that metabolize methane, may indicate something of the possibilities for life on other worlds. Quote, "Astrobiologists treat unusual environments on Earth, such as methane seeps and hydrothermal vents, as models for extraterrestrial ecologies," writes Helmrich. Cassini has revealed that several of Saturn's moons have liquid or frozen oceans and briny geysers. Enceladus, with its outgassing plumes of ice, water, and salt, and Titan are of particular interest. As the planetary body in the solar system most similar to Earth in atmospheric composition, Titan could reveal how life on Earth emerged, suggests astrobiologist Chris McKay. Since Titan and Enceladus are likely heated internally by Saturn's gravitational squeezing, astrobiologists imagine that extremophiles might huddle near hydrothermal vents on the floors of their Arctic seas. On Earth, Lake Vita in the Antarctic has been capped under a 50-foot thick ice sheet for 2,800 years, and yet researchers found ancient microbial life thriving there. Helmrich comments, quote, "For astrobiologists, life, extremophilic or no, will exist in a liquid medium. It is for this reason that extraterrestrial seas, alien oceans, are such objects of fascination." End quote. In these discoveries alone, the implications of the Cassini mission are as deeply cultural as they are scientific. I have not heard of The Sky at Night. I don't think. Maybe I have. Maybe someone's mentioned to me. I haven't watched it. Let me look it up. A team of astronomers gives us an in-depth look at what is on show in the night sky. Oh, that sounds really cool. I think people have definitely mentioned it to me, but I don't believe I've... Are you serious? Has it been going since 1957? Oh my god, that's insane. Yeah, you just said world's oldest astronomy program. That's amazing. That's really, really cool. Oh man, I gotta give it a watch. That's awesome. I'll have to find it somewhere online because I don't have cable. But you're the producer. Oh my god, that's so cool. That's amazing. Wow. That's so cool. Wow. Yeah, I'm hella gonna watch it now. Oh my god, I know the producer. That's really, really cool. Oh man. That's awesome. Oh, and Student McLeod, thank you for yeah, if you guys are interested too, Student McLeod just dropped the link to the Sky at Night BBC's page. It's really cool. Wow. He also dropped a link to the caffeine molecule, which is, yes, you're right, what I need. Oh, that's so cool. If you want Professor Chris Impey, if you know him, to be a guest, I have an in. If you want me to be a guest, I'm kidding. But we work with Professor Impey. I don't know if I don't know how the astronomy community, I don't know if people just like know each other. I don't think he's ever been on the show, but he's from the UK. I was gonna say the town, but I don't actually remember where he grew up. But yeah. Okay, I'm gonna keep on going while you guys talk about Sky at Night. All right, let's see. Robotic and biological symbionts. Okay. Robotic and biological symbionts. In the introduction to the stunning coffee table volume, Saturn, A New View, Kim Stanley Robinson comments on the amazing photographs Cassini has archived in its ongoing exploration of Saturn. Noting that, quote, the gorgeous concentricities of Saturn's rings look like gravitation itself made visible, end quote. Robinson is wistful that astronauts have not yet journeyed to Enceladus or Titan. Quote, eventually, we might even go to Saturn ourselves, writes Robinson. It would be a kind of pilgrimage. It would be a sublime experience, end quote. However, roboticist Rodney Brooks would likely argue that we have already journeyed to Saturn and landed on one of its moons. NASA's planetary missions are extensions of ourselves. These little machines, with the ability to travel billions of miles across the chasm of interplanetary space, enhance our vision, like a pair of contacts or glasses, and extend our sense of touch, our ability to sample the atmosphere of another world. analogous to cochlear implants, pacemakers, or titanium prosthetic legs that allow paraplegic athletes to run faster than Olympians. Cassini has taken us to the far shores of the outer solar system and continues to record in fine detail the state of affairs at Saturn and its moons. Cassini, like our other planetary science missions, serves as a highly technical extension of humankind. These robotic explorers not only extend our fingertips into the frigid outer solar system, but Brooks argues that our machines are us, and that biotechnology of the future will reconfigure what we think of as human. Quote, "Our machines will become much more like us, and we will become much more like our machines," predicts Brooks. "The distinction between us and robots is going to disappear." Unquote. Futurist Ray Kurzweil couldn't agree more. Kurzweil predicts that in the next 30 years, we will use biochemistry, biotechnology, and nanotechnology to reconfigure the human body, in part by readily incorporating technology into our bodies to enhance longevity and our intellectual capacity. Kurzweil points to the evolution of sight to illustrate how technology has exponentially enhanced our biological capabilities. Quote, "There are many ramifications of the increasing order and complexity that have resulted from biological evolution and its continuation through technology. Consider the boundaries of observation. Early biological life could observe local events several millimeters away, using chemical gradients. When sighted animals evolved, they were able to observe events that were miles away. With the invention of the telescope, humans could see other galaxies millions of light years away. Conversely, using microscopes, they could see cellular-sized structures. Today, humans armed with contemporary technology can see to the edge of the observable universe, a distance of more than 13 billion light-years, and down to quantum-scale subatomic particles." End quote. Kurzweil compares this exponential advance in visual observation to the evolution of information technology. He notes that microorganisms can respond to and communicate events in their immediate environment, but with the evolution of humans, language, and the technology of writing, we have recorded information that persists for thousands of years. The simple technology of writing, whether in cuneiform or in modern languages, has exponentially expanded our scientific knowledge and reach. Our robotic partners in space are no less an extension of ourselves than a telescope or the technology of writing, and have powerfully shaped what we know about our planet and the solar system, and the billions of worlds we have yet to explore. What are you guys talking about? You guys talking more about the program? You should check him out. He's great. You have Adam Seltzner, the Perseverance chief engineer. Oh, amazing. And Tim Peake, a British astronaut on the coming show. That's so cool. That sounds so cool. I actually want to work in film and TV. I'm living in Los Angeles for those who are new here. And I studied film and television, but I've been with the astronomy group for like 4 years now. And I'm trying to get into children's animation, writing for children's animation, because that's what I love to do. Oh, it only airs in the UK though? Oh, damn. Maybe I'll get myself a VPN and find it that way. But yeah, that sounds so cool. Oh my god. Adam Stelzner is going to be a great guest. Oh, that's going to be really cool. All right, let's see. Even now, we are joint explorers with our smart machines. Anthropologist Stefan Helmrich comments, quote, "What it means to do oceanography and ethnography is changing. In an age of remotely operated robots, internet ocean observatories, multi-sited fieldwork, and online ethnography, presence in the field is increasingly simultaneously partial, fractioned, and prosthetic. It is not just distributed across spaces, multi-sited, but cobbled together from different genres of experience, apprehension, and data collection." End quote. This collaborative scientific exploration, already being undertaken between humans and machines, affords us a kind of distributed intelligence across the solar system. Helmrich, Brooks, and Kurzweil suggest that we think of our machines as symbionts, without whose help we could not explore Earth's ocean depths, much less the depths of lakes and oceans on icy moons orbiting Jupiter or Saturn. Our collaboration with smart machines incites Helmrich to consider one other order of unsuspected collaboration, that between humans and microorganisms. He suggests that alien microorganisms, if such exist in the frozen ocean, on Enceladus, or in Titan's hydrocarbon lakes, may be more akin to life on Earth than we imagine. As microbiologist Joe Handelsman points out, quote, "We have 10 times more bacterial cells in our bodies than human cells, so we're 90% bacteria," end quote. Of the microbes coexisting in our bodies, scientists explain that we have, quote, "evolved with them in a symbiotic relationship, which raises the question of who is occupying whom," end quote. In fact, instead of thinking of microorganisms as alien to us, doctors have begun to recruit them in fighting cancer. Researchers at the University of Pennsylvania are relying on our symbiotic relationship with viruses and other microorganisms to attack and kill cancer cells. They're using viruses to insert DNA into patients' T cells that in turn cause the T cells to selectively attack and kill cancer cells. As Stefan Helmrich makes clear, quote, "Microbes are not simple echoes of a left-behind origin for humans, orphaned from all evolutionary association. Microbes are historical and contemporary partners, part of our body's microbiomes. The human genome is full of their stories. The bacteria that inhabit our bodies do not simply mirror the bacteria that inhabit the sea, as might brine in our blood. This is not human nature reflecting ocean nature. It is an entanglement of natures, an intimacy with the alien. Such dynamics shift the grounds upon which anthropos might be figured, perhaps transforming humanity into Homo alienus." End quote. Evidence of this is the fact that people in different regions of the world have different genetic makeup, partly due to local microorganisms. People of Japanese descent have, quote, "acquired a gene for a seaweed-digesting enzyme from a marine bacteria. This gene, not found in the guts of North Americans, may aid in the digestion of sushi wrappers," end quote. As noted in the chapter on the Viking mission, Lynn Margulis's contribution to Gaia theory was to highlight the extent to which our existence is intimately bound up with the Earth's microorganisms. Having proposed the theory of symbiogenesis, which claims that the mechanism for evolution is the symbiotic sharing of genetic material, Margulis demonstrated that bacteria invading single-celled organisms become their mitochondria and chloroplasts. We do not know whether extremophiles exist on Titan, Enceladus, or other worlds such as Europa, one of Jupiter's moons. What drives our continued exploration of those distant shores is that our beginnings may be entangled with theirs. That's the end of that section. Guys, we're talking more about stuff. Do you get a VPN? You shouldn't be saying that. Yeah, VPNs are fine. 800. Have you done 800 episodes? Oh my god. That's crazy. Oh my goodness. That's such a cool legacy to be a part of. Like, oh my gosh. That's so cool. That's so cool. Oh my gosh. If you don't mind me asking, what was your first episode on the show? Like, how long have you been a part of it? That's really, really cool. Oh, you guys have a mailing list too. Yeah. There you go. Some astronomical highlights as well. Yeah, for those who can't use a VPN or isn't in the area, Single Coded said that there's a mailing list where you can get some of the highlights and stuff. That sounds cool. Looks like we only have, I think, just about a page left, and then we can chit chat for a little bit and we'll wrap it up. Wow, that's crazy. Sir Patrick Moore was the presenter of it for 56 years and only missed one episode due to food poisoning. That is, wow. That's amazing. That's so cool. Ugh. Shout out to Sir Patrick Moore. I'm assuming he has since passed, but hell of a guy. Sounds like a hell of a guy. All right. Let's finish this off. Is there life on Saturn's moons? Huygens was a pinnacle among many high peaks for the Cassini mission, marking the first time humans had landed a spacecraft on any body in the outer solar system. It saw a terrain sculpted by wind and liquid, with vast hydrocarbon dunes and sinuous channels carved into the shoreline. Volcanoes in the distance are likely to emit water instead of lava. Meanwhile, a tepid ocean sits under the icy crust of Little Enceladus. These two moons are worlds at once alien and familiar, and if they host life, it will be unlike any form of life known on Earth. In 2011, the sum of all the evidence so far caused scientists at a major meeting to elevate Enceladus to the status of the, quote, most habitable spot in the solar system, beyond Earth, above Titan, and even above Mars. One of the conundrums of the search for life beyond Earth is the difficulty of moving away from Anthropocenic thinking. All life on this planet is one thing, derived from a single common ancestor and a single implementation of information stored in genetic material. There's no way to inductively formulate a general theory of biology, or know how life might have evolved if conditions had been slightly different, or if it would have evolved at all. Since the hypotheticals cannot be answered, we don't know whether the origin of life on Earth was a historical accident or the nearly inevitable outcome of physical and chemical conditions plus the passage of time. These two scenarios project very different roles for life elsewhere in the universe: sparseness or abundance. We do know that life has adapted to almost every conceivable ecological niche on the Earth, including environments below water's freezing point and places where the source of energy is not sunlight or photosynthesis. Life grips the planet like a fever, thriving in almost all places we can imagine, and in some that are nearly unimaginable. If Titan and Enceladus host life, we'll not just have to expand the envelope of our traditional thinking about life processes, we'll have to throw away the box completely. If the moon of a giant planet is hospitable to biology, then by focusing only on finding Earth-like terrestrial planets, we'll be missing a large part of the story. If a tiny moon far from the sun can be habitable, the number of potential living worlds throughout the Milky Way galaxy rises dramatically to several billion. Biochemistry based on ethane and methane, augmented by water and ammonia, would be unlike anything we've ever seen on Earth. Computer and lab simulations might help, but we still know too little about physical and chemical conditions on these moons for them to be reliable. The next time window to get a gravity assist and revisit the Saturn system is 2015 to 2017, which adds a sense of urgency. I guess that has passed already. Which adds a sense of urgency since the opportunity following that one is not until 2030. That one has not passed. Cassini and Huygens have given us just a taste of the potential for life beyond Earth. If we want to address this profound question, we'll have to go back. And that's the end of that chapter. And I saw that there were a bunch of chats, and I'm going to catch up to them. Also, I saw Keaton Stone, you said one thing, and it didn't actually post because it didn't like a word you used, even though it's just somebody's last name. That's funny. That was a great chapter. That was fun. Lots of stuff about life in the universe. Like being reunited with an old friend. So that last chat that came through from Keaton, they put up earlier. You first worked on it in 2007 until 2013, and then did lots of Professor Brian Cox shows. Yes, that was the one. That's so funny. For a few years and some other stuff, and then returned to it recently. Oh, that's so nice. You lived with Stephen Hawking for 6 months. Oh my gosh. That's amazing. Hi, Bill Nash. I mentioned you before, calling all of us nerds. We're just a big old group of nerds. I love it. Oh, nice. Single Coded posted an example of one of the Sky at Night magazine newsletters, so you get all the information about good stuff to see this week, this week in space history. Hey, we were talking about this last time. There you go. That's so cool. I guess this was closer to actually when we were talking about it. That's so funny. But yeah, it's a cool little newsletter that they got. If you can't access the actual show, Sir Patrick passed away in 2012. Yeah, may he rest in peace. He sounds like he would have been a really cool person to meet. What else? I think we may have stumbled upon someone to interview on Wednesday or Friday. Yeah, Keaton Stone. I don't know. I'm sure you're plenty busy, but we do interview people when we have the chance. So if you would ever be interested, let me know. I would love to talk to you about some of your time working on all these really cool astronomy programs, and like because Professor Impey, who is like the person kind of behind all of this stuff, he's the reason that I'm part of the student group that exists, and the reason that the student group has since made this Twitch channel and stuff like that. His whole thing, he did like blazar and some black hole research earlier in his career, but since he got to the University of Arizona for the past like few decades, I think, he is focused on astronomy outreach and education and research in education. Love to hear from somebody like you who does education, like astronomy education outreach in a I guess traditional media format. Yeah, I'm going to you should email me, because I would say I'll email you, but then you would have to put your email here, and I don't think you want to just publicly put your email here. But activegalacticvideos@gmail.com. Also, if anyone wants to send questions for things, or like suggestions for stream ideas, you guys can send those to that as well. But that would be super cool if we could have you on the show. Oh, that would be great. Yeah. I will find you on the Twitter. Yeah, what else is going on? Sir Patrick had the very special distinction of meeting in person the first person to fly, the first person in space, and the first person on the moon. That is so cool. That's so cool. Oh, man. All right. Well, I think that about wraps it up for today. If you are going to join us for next week, which I hope you do, next chapter is going to be about... I lost my page. Stardust, which is a comet mission. That's not the name of it, is it? Is the Stardust spacecraft. I did not know that. But it's a comet mission. So if you want to learn about how we caught a comet, or caught its tail, be sure to be here next week, Mondays at 10 a.m. Pacific Standard Time. But like I said earlier, on Wednesdays we do astronomy news chat, and or this week we're actually going to be doing an interview with one of our other students on the student team, so you get to know them, because we have a few other people on the team that don't stream. They focus on other things, and they do their own research and stuff, and I thought it would be fun to have them on and have them talk about their research and things. So we're going to have a guest on Wednesday, and then on Friday we're talking about more amateur astronomy stuff, and I believe we had a plan to focus on... Oh, I think everyone's going to be sharing their amateur astronomy setups, so be sure to come by, take pictures of your astronomy setup. There's an excuse to go look at some stars this week, and share it with us, and we're going to just like talk and geek out about telescopes. And then I think that's all the housekeeping stuff. Professor Impey's Q&A stream is on YouTube this week at the Astronomy State of the Art YouTube channel. Also, if you're looking for the archive of the older chapters of this, if they're not on Twitch still, they're on Teach Astronomy on YouTube. And I think that's pretty much it. We're also a Twitch affiliate, so you guys can... subscribe if you want to help support the channel. If not, make sure you follow at least, and get notified when we go live. And I think that's it. So I hope everyone has a good rest of their day, a good rest of the start to your week, and I will see you all on Wednesday. Bye.